here is an example. We are going to show how to find the sum of a series recursively. The first step we're going to try to do is find the recursive formula. So we're going to try to find the relation between Sn and Sn minus 1. Okay. And for this series, it's pretty straightforward. We see that Sn minus 1, just look at what's going to be the last term, and this is n minus 1, right? So we can easily see that Sn is equal to Sn minus 1 plus n. So this one over here is recurrent relation, we usually say. This is the recurrence relation. Okay. And then we try to solve it. And this recurrent relation is linear, because we see over here, this one over here is linear. Linear means you have this kind of form. Sn is equal to a constant times Sn minus 1 and plus something over here. And this something over here is the non-homogeneous term. In our case over here is n. Okay. And to find the formula of Sn, we need to guess, we need to make a guess. We need to make a guess of the form of Sn. Okay. And we explained in class that because we have this sum, 1 plus 2 plus 3 and plus n, this is just a reasoning, is equal to roughly the integral from 0 to n, or 1 to n, that doesn't really make any difference, and x dx. And this one over here is 1/2 x squared and n 0, and that's 1/2 n squared. So we guess that Sn has the formula at an squared plus bn. It's a polynomial of degree 2. This is polynomial of degree 2. Now, this part is not necessary because it's just our part of our reasoning to guess. This form of guess actually works for other series as well. Okay. So this is the form. Now we need to find a and b. These are constants. Okay. So now we come to the part 3, how to find AB. Find AB. We know that we want this one to be true, an squared plus bn. This should be true for all n. For all n. N is 1 and 2, etc. So we say S1 must be equal to A1 squared plus B times 1. And we know what S1 is. S1 is simply equal to 1. And then we look at the second one, S2. And then we have A2 squared and plus B times 2 is equal to S2, remember, is 1 plus 2, and that's 3. So we obtain two equations. One is A plus B is equal to 1. The other one is 4A plus 2B is equal to 3. Now, in general, we can use Gaussian elimination to solve this. But for this one over here, we can easily see that we can use a rather simple way to solve it. It's the same idea as Gaussian elimination. So we multiply 2 to the first equation because we see we have 2b in the second equation, right? And then we use the second equation minus the first one, and then we will have 2a is equal to 1, and then a is equal to 1/2. If a is equal to 1/2, so b has to be also 1/2. And then we have the formula, is the exact formula for Sn. So we have this, again, this is only a guess for the moment, and that's Sn is equal to 1/2 n squared plus 1/2 n. And we have verified at least this formula is true. This is true for n is equal to 1 and 2 because we have just did it. And the last step over here is the induction. Now we need to verify this formula is true for all n. Verify the formula holds for all n. And we use induction over here. So the induction has 3 steps. Step 1, we show that S1 is really true. When n is equal to 1, S1 is equal to 1/2 1 squared plus 1/2 1. And that's 1. That's verified. And then we assume it is true for n minus 1. So when n is equal to n minus 1, you can use the change a different symbol, k minus 1. And then we have k minus 1. This is the induction assumption. 1/2 k minus 1 squared plus 1/2 k minus 1. And then we verify it is true when n is equal to k. That means sk, we remember the recursive formula is that sk is equal to sk minus 1 plus k. This is from recursive formula, or our recurrence relation, right? And then we use this assumption at k minus 1 squared plus 1 minus k minus 1 and add k. Our hope is that we will get the same formula. Then it's verified. So this one over here is going to be 1/2 and k minus 1 squared plus k minus 1. We factor 1/2 out so that we can simplify. So we got to simplify to see the formula. And 1/2, and this is k squared minus 2k plus 1 and plus k minus 1 and plus 2k. And then we see that this is going to be 1/2 k squared and plus k. And that's exactly the formula that we have. So the same formula. This is the same formula as we guessed, as we proposed. Okay. And then we are done. So our final answer is that, so Sn is equal to 1/2 n squared plus 1/2 n for all n, 1 and 2, etc. In fact, this formula holds even when n is 0.